Let A be a square matrix of order 2 with entries either 0 or 1. So we have a 2 cross 2 matrix and each entry is either 0 or 1. Let E be the event that matrix A is invertible matrix. Invertible matrix means determinant of that matrix is non-zero. So then we have to find probability of this event E. So first let us find the sample space here. We have a 2 cross 2 matrix and the entries are either 0 or 1. So let us say we have a general 2 cross 2 matrix with entries A, B, C, D. First row is A and B and the second row is C, D. Now each entry is either 1 or 0. So that means for each one of these four elements of this matrix, we have two options, right? So therefore, number of elements in sample space or number of matrices, this will be 2 raised to 4 or 16. For A, we have two options. Either we can take A as 0 or 1. For B, we have another two options and so on. So using multiplication rule, the number of matrices that you can create, this will be 16. Now let us talk about favorable cases. Favorable cases are those cases where determinant of matrix is non-zero. So total we have 16 matrices. First we'll find those matrices whose determinant is 0. Right. First we'll count the number of matrices whose determinant is 0. Determinant 0 means AD minus BC, that thing is 0. Right. And total we have 16. So the remaining matrices will have determinant non-zero. Now if I want to make determinant 0, then there are number of different possibilities. The very first possibility will be, we have to use only 0 and 1. So we'll consider different cases. One case we'll consider where we are using all zeros. Next case we'll consider where we are using 3 0 and 1 1. And then we have 2 0, 2 1, right? And in that manner, we'll see what are the different cases that we can create. So the very first case we are creating is where I'm using only zeros, right? We are using all the 4 0 and we are not using any 1. So in this case, clearly you can see that you will get one matrix whose determinant will be 0. First we'll count number of matrices having determinant 0 and then total minus those matrices, that will give us number of invertible matrix, right? So one possibility we are using all four elements as 0. Next possibly, in this case, you'll get only one matrix, right? There will be only one matrix with all entries 0 and determinant is also 0. Next possibility is that we can use 3 0 and 1 1, right? We are using 3 zeros and then we have 1 1. Now in this case, how many matrices are possible? So clearly you can see that in this case you can create 4 such matrices. In first case you'll get only one matrix, but in this case you will get 4 matrices by changing the position of this element 1, right? This 1 will be either in first row, first column, first row, second column and so on. So in this case we are going to get 4 matrices. Next possibility is that we can use 2 zeros and 2 1. Remember in first case we were getting only one matrix, right? In this case we got 1. In second case we got 4. Now next possibility is that we are going to use 2 0 and 2 1 and then again count how many matrices we can create. So again, if I have to use 2 0 and 2 1, we need to keep those 2 zeros in same row or same column, right? So for example, this is one matrix whose determinant will be 0. Now in this particular matrix, we are taking 2 zeros in first row, but we can take 2 zeros in second row also, or first column or second column. So here again you can create 4 matrices using 2 zeros and 2 1 whose determinant will be 0. Remember, if I have 0 on diagonal and off diagonal elements are 1, then determinant is non-zero, right? So these are the four matrices will be first row 0, second row 0, first column 0 and second column 0. So these are the 4 matrices that you will get when you are using 2 zeros and 2 1. Next possibility is if I use only 1 0, if I use only 1 0 and 3 1, then you cannot make determinant 0, right? In the same example you can see that if I use only 1 0 and 3 1, then determinant will be non-zero. So in that case we'll not get any matrix. And so the last case will be that if we are using all 1 and none of the elements are 0, then also you can get a matrix with determinant 0, right? If all the 4 entries are 1, then also determinant will be 0. So here we are getting one matrix. right? So if we talk about total number of matrices with determinant 0, clearly you can see that 4 plus 4 plus another 2. So there are 10 matrices whose determinant is 0. So that means for remaining 6 matrices, the determinant will be non-zero. And therefore, probability of this event E, that a randomly selected matrix will be invertible matrix, this will be 6 by 16. Right? There are 6 matrices with determinant non-zero, total 16. So this will become 6 by 16 or 3 by 8. And hence the correct answer will be option E. So this was a very simple problem and you have to just count the different cases. So always start with the extreme case and then see what are the different possibilities, right? For favorable cases, first we are counting those matrices whose determinant is 0. Now you can use 40 or 3011 or 2021 or 1031, but in that case you will not get determinant 0, and finally all 4 1, right? So we have considered all the 5 possibility and these are the number of matrices whose determinant is 0. So remaining 6 matrices will have determinant non-zero and hence probability will be 6 by 16 or 3 by 8, and the correct answer for this problem will be first option.